Have you ever wondered if the concept of convergent evolution could challenge the fundamental principles of Darwinian evolution? Let's dive into this intriguing question. Darwinian evolution, at its core, proposes that species evolve and adapt over time through natural selection. Now let's introduce the concept of convergent evolution. This refers to the independent origin of similar traits in widely divergent species. An article titled "Claims About Convergent Evolution Are Absurd" lists an impressive number of so-called convergent evolution occurrences. For instance, it mentions C4 photosynthesis occurring independently 60 times, eyes evolving 35 times, and bioluminescence developing 27 times, to name just a few. Renowned evolutionary biologist Simon Conway Morris sees convergent evolution as more than an oddity. He considers it a driving force of evolution. With such compelling examples, we have to ask ourselves, does convergent evolution challenge the core tenets of Darwinian evolution? Let's delve into the intriguing case of butterfly mimicry, a striking example of convergent evolution. Butterfly mimicry is a phenomenon where unrelated butterfly species evolve similar physical characteristics. It's like nature's own version of a masquerade ball where species wear the disguise of another to gain some survival advantage. Now this is where things get interesting. Bernard de Brera, a renowned butterfly scholar, challenges the likelihood of such mimicry occurring by chance alone. Imagine winning a lottery. The odds are incredibly small, right? Now, imagine winning that same lottery not just once but multiple times. Seems highly improbable, doesn't it? Well, this is essentially what we're expected to believe with butterfly mimicry. De Brera points out that it's one thing for mimicry to happen once in a single species due to a lucky roll of the genetic dice. But when we see it happening over and over again, in numerous species, the math just doesn't add up. Either we're grossly misunderstanding the capabilities of mathematics, or we're turning a blind eye to an inconsistency within Darwinian evolution. And it's not just about butterflies. The same mathematical improbability applies to other instances of convergent evolution. Take bioluminescence, for example. This is the ability of organisms to produce and emit light. This trait has supposedly evolved independently at least 27 times. Or consider the evolution of eyes, which is said to have occurred independently an astonishing 35 times. The sheer frequency of these occurrences seems to challenge the notion of chance and randomness fundamental to Darwinian evolution. It appears that we're dealing with something more than just a roll of the genetic dice. Could there be a different driving force at play here? One that we're yet to fully understand? Evidently, the frequent occurrence of such a complex phenomenon challenges the probability aspect of Darwinian evolution. The concept of convergent evolution not only challenges Darwinian evolution but also disrupts the logic behind common ancestry. Let's delve into this conundrum. Casey Luskin, a prominent voice in this debate, argues that the very moment evolutionary biologists have to resort to convergent evolution, it signifies a breakdown. It's a crack in the main assumption of evolution and exposes a struggle to fit the data into a neat tree-like pattern. This, he suggests, is a fundamental challenge to the Darwinian model of evolution. Now let's take a step further with Cornelius Hunter's perspective. He contends that the 21st century evolutionists are still grappling with the prevalence of convergence in biology and its occurrence. Hunter goes as far as stating that convergence is a problem for the theory of evolution. He asserts that the species do not fall into the expected evolutionary pattern, thus falsifying a fundamental evidence and prediction of evolution. He sees this as a hard failure, which he believes is fatal for scientific theories, reducing evolution to an ad hoc exercise in storytelling. Then we have Gunter Beckley, who debunks the myth of a congruent nested hierarchy in evolution. He argues that it's an epic myth perpetuated by evolutionary biologists that the similarities between organisms mostly fall into a hierarchic pattern of nested groups, suggesting common ancestry and indicating phylogenetic relationship. Beckley states that in reality, this claim is contradicted by a deluge of incongruences and reticulate patterns. These patterns, he contends, cast doubt on the fundamental paradigms of evolutionary biology, such as the notions of homology and common descent. Clearly, the existence of convergent evolution raises fundamental questions about the validity of Darwinian evolution. Our exploration of convergence and its implications continues to challenge the traditional narratives of evolution, adding another layer of complexity to our understanding of life's rich tapestry. Imagine this, an octopus and a human, two vastly different species, yet sharing key genetic similarities. It's a peculiar thought, isn't it? These two entities, one a master of the oceanic world and the other dominating the land and air, both possess high-powered brains and camera eyes, complete with a cornea, lens, and retina. These complex structures and capabilities didn't just appear out of nowhere. They are the result of millions of years of evolution, encoded in the genes passed down from generation to generation. But here's the catch. According to neo-Darwinists, humans and octopuses don't share a common ancestor, at least not in the recent several hundred million years. This is where the concept of convergent evolution comes into play. It's the idea that unrelated organisms can develop similar traits independently, in response to identical environmental pressures. So, in essence, the evolution of these shared traits between humans and octopuses had to happen twice, once in the lineage leading to humans and once in the lineage leading to octopuses. The researchers who sequenced the octopus genome term this as a striking example of convergent evolution. But isn't this just a sophisticated way of saying that a miracle occurred twice? This brings to mind a humorous observation by Eric Metaxas. He quipped, "What's the difference between evolutionary theory and an octopus?" Well, one is a slippery, color-changing escape artist that can get out of any tough situation, and the other is an aquatic invertebrate. While Metaxas's comment is clearly tongue-in-cheek, it does highlight a significant conundrum. How can we reconcile these striking examples of convergent evolution with the traditional Darwinian model of evolution where organisms are supposed to fall into a tree-like pattern? So, does convergent evolution debunk Darwinian evolution? Well, if empirical evidence is to have any say about whether Darwinian evolution is true or not, then, as Cornelius Hunter noted, this is a hard failure for Darwinian evolution. A fundamental evidence and prediction of evolution is falsified.